Joyce. Happy day before the AP. We are talking about what I want you to... What's that from? Anyway, everyone's been laughing.
Freaking Josh!
It's the best show ever.
Megan. It's like little sister always pulls.
We're talking about Katrina's campaign poster, in case you're wondering.
Yeah, it's funny. Drake and Josh. Awesome.
Oh, Drake and Josh. I have heard of that one. I thought you said something totally different. Okay.
Drake and Josh?
Isn't like Josh like great indoors now? Isn't like the actor for Josh?
I thought Josh only did mine.
Yeah, he's really nice.
I think he's on this show called The Great Indoors now.
Maybe. Okay.
So can we watch Drake and Josh tonight? Binge watch that instead of sleeping? It needs to be on Netflix.
All right, Joyce. My question was, what are we going to do tonight? All right, ready, set, go.
Sleep.
Good. Sleep is important. What else?
Chillaxer.
Look over your favorite endeavors. Quickly review.
Don't eat a super heavy meal, right? Make sure you get good sleep.
Good one. Don't dream weird dreams.
Don't, I'm not sure if you're
I
totally
had
charged with
such
that.
a weird
Don't
dream on
text in the group
Saturday.
chat.
I had two
I
weird
was
dreams this week.
freaking out.
Probably the drugs.
No, I wish.
It wasn't the NyQuil? The DayQuil? Whatever.
No, it was like a nap.
Wait,
Oh, I'm feeling better.
you sound better.
Yeah. Dropped the Dayquil.
How
took
did
up
you bounce
Tylenol,
back so fast?
Took Tylenol, cold and flu. Severe
man.
cold and flu.
There you go. So really just drugged up.
Chelsea.
Okay, so you're gonna get sleep. You're gonna eat fairly smartly tonight. Fairly well. What are you gonna go over? What are you gonna review? Forever's endeavors, especially mistakes on your Forever Endeavor final. Joyce, yours is graded back to back somewhere. What else?
Don't worry.
Lagrange.
Yeah, maybe areas of weakness that you know specifically. You can even go find. You guys know how to find sample problems to whatever you want.
The next textbook.
What else? Huh?
Study the
Speaking of the
textbook.
textbook, can I bring it in tomorrow?
Tomorrow?
Can I
No.
bring it back to you?
You should not be focused on bringing in your textbook tomorrow.
No, I mean like, can I give it back to you?
Oh, like after the AP? Yeah.
That reminds you of the this one it's like this is gonna be on the
Pause! What else are you looking at tonight?
I feel like there's something that
Related
should be,
rates?
but I don't know.
When?
you see you think.
There we go.
I don't even know what that is.
It's at the top of the page, but that's alright. Who's looking? So, when you see you think, that's another good idea.
What if I don't
I have a document from a... Who's you?
Do
pretty
we
reliable
just
source.
support like blind people? And, is that, like,
What are we
can a blind person
talking
take AP?
Yeah, that's a good question.
I don't know, but you're not blind right now,
Sorry,
so let's
no,
just
that
keep
just came
going.
into my mind. Because, like,
That's a
what do
very
you else
interesting question. You can Google that tonight right before you go to bed. Actually, no, right when you get home. Don't be thinking about that right when you go to bed.
do? It's so interesting.
What if I went blind? Could I still take it tomorrow? I'm not sure you can learn it in time. So, anyway, coming back. We are going to go ahead and go over a document that says what to expect in the calculus. Now, this is from 2014, but I promise the topics haven't really changed. So I figured we could go over, just because specifically BC free response, these are the main categories of what they could ask, and reminding you guys any formulas that you don't have shored up that was not on it Forever Endeavor final to make sure you have for tomorrow. So we're going to peek at that really fast. And other items to review. That's just kind of random over and above. I do technically have the 2015 international exam, which is one that I think you guys might have seen some of the questions on your AB final exam that we took. Actually, I think it might give you a different years. But we could go through and we could find BC only questions or like related rates. You guys saw a few, area, volume, etc. We could look at FRQs if you guys wanted. There was a polar area one in there that was kind of messy. I do have Jeopardy really close and ready. The problem with Jeopardy is it's only AB plus parametric. So I don't mind doing that a little bit, but I don't want that to be all, because I do want us to at least talk about BC a little bit. Because that's your test tomorrow. And besides that, you guys know how to go on here. And besides that, if anybody was doing any of the practice stuff from the website over the weekend you got stuck on, I don't mind answering questions now either. Does that make sense? So if you guys have any questions that you were going over that you would like a little further clarification on, you can go ahead and grab those out and we can look at them. If you just tell me where it was from, I could find the sample AP. So get that ready. But as we get that ready, I'm going to go ahead and come back to the main topics that we need to know for the BC free response. And if you guys are wondering if you could find this on your own, not that you necessarily want to, But what to expect in the BC exam, right there. I think pretty much like there's like the most missed released AB questions that we looked at a little bit last year in AB. If you guys want to look through, those are like the tricky AB ones, whether graphs of derivatives, weird tangent lines that hit at a point. That's on there. Things I wish I would have told them. This should be stick it to the man. Don't cross out your work unless you know that you have time and can do it better. Label with units. This is pretty much everything that I talked to you guys all year. Don't do something dumb.
I know.
Anything else? Don't use it, so you guys know not to do that. Write the limits and the constant even if you can't know the rest. If you don't know how to do A, just make up something, use it in B. Know how to use your derivative. Sorry, your calculator. I think you guys are good at all that. It's not that it's a bad thing, but always write good math. Anyway.
I feel bad for the person that's the grade.
No, don't, because they would rather you write that and they can see it. They have that question memorized and all the different variations of how to solve it, and they have like this whole little like work booklet on all the different things they can see. Don't you dare feel bad for them, because they are just fine, and they would rather see that answer. As a teacher, they would rather see the stick it to the man answer than see someone simplify it wrong.
And it's only like this times this and A plus B bubble.
You just have to plug in.
Yeah, plug in.
You don't have to
You don't have to add, multiply, divide, subtract, bring in a fraction or a root or a power.
But in reality, you have to add
Unless it's a multiple choice, then you might have to do some of that annoying arithmetic that you always have to do. All right, kiddos, let's go ahead and start on this. So, Power, Taylor, McLaren. Some of you guys missed the McLaren series. Oh, so sad. Or you missed the definition of a Taylor series, so make sure that you have those things worked out. Don't forget your factorials. Remember a lot of you guys didn't like the find the 10th derivative of f without actually solving it using the series. Huh? This one, the top one. But we do f of c.
Oh, so it's
F of c. Like for any function.
That's the thing.
That's the definition.
Oh.
So we have memorized Maclaurin ones, but we can always build a Taylor series if you have a function and I find your first derivative, second derivative. Right?
What happens when like you get the derivative starts to equal 0?
If the derivative equals 0, then I think the Taylor Maclaurin, isn't it, defined that it has to be differentiable to the nth degree?
No, because there's a Taylor Maclaurin type of thing for 1 over 1 minus x. So that has a limited number. No, it has an infinite. J. Okay.
Make sure for your interval of convergence, a lot of you guys in your forever never final forgot to put, not for the radius, but for the interval, you forgot to put test the endpoints, and I think you missed, some of you missed that on your copies as well. Make sure for your alternating, that's the next term. A couple of you guys missed that in your forever endeavor, and then you guys know with Lagrange, with your interval, your convergence and divergence, just make sure that you have those worked out as far as the limit comparison test. That was like the roughest question on the forever endeavor final. The limit is much better than the direct comparison, but some of you guys got the two like mixed in between. There's going to be convergence and divergence tomorrow. You guys know area and volume. The most important thing is to understand discs and washers, and then if you can do shell method, that's great. That probably only require shell method on maybe 1, maybe 2, maybe not at all though. You might be able to solve it with discs and washers no matter what. They say this will probably be one of the 4 non-calculator problems. It kind of depends on year to year as to what shows up and why. But they are trying to be like, hey, it's almost guaranteed there's going to be some sort of area volume on the FRQ. That is pretty normal. For your polar equations, a few of you guys still need to work out some of these formulas as far as, I think we're doing okay because we've done this more recently with the 1/2 r squared, what we put in. But the difference between area between and area inside both. Are we okay in our calculator as far as we have it in simultaneous mode? when you go to polar, make sure that you're looking for those intersections. You can go to function to find the zeros, etc. Roberta?
For like area and like the surface of revolution ones, is that like ones we have to solve, or we can just sorry, I don't say this like you just, if they give you y in terms of x, you just use that, or if they give you x in terms of y, you just use that.
It depends. Because if they give you something like cross sections perpendicular to the x-axis, you have to go dx, and they might give it to you in terms of x, and they might not. Yeah, I'm not sure we can say that for sure. I've seen it go both ways. Analyzing graph of the derivative. Hopefully, this is one of our easiest ones if it does show up. In the sense of finding relative maxes, relative mins, in the sense that if you're given a function in terms of the integral of another, what would the derivative of g be? What if that was a u? What if it was x squared? What would g prime be?
f of x squared times 2x.
F of u times u prime. G double prime is going to be then the derivative of that and following an f prime. Hopefully we're good on that. Parametric, just make sure you know your formulas as far as arc length. Speed, that was something that was a little bit rough on the front end of the final as well, as far as with our vectors and as far as with our parametric. Remember, total distance traveled is the integral of speed, whether that's in parametric or whether that's just normal absolute value of velocity, it just depends. If there is a table, you guys know what to do with the Riemann sums or with your different theorems that might appear, how to do average value. Wait a minute, what's the difference between average value and average rate of, say, f?
Average rate, you have a function, you want to find the like derivative, there it goes, and then the average value, you have the derivative, and then you want to find the average, not rate, but the average amount.
Yeah. Yeah, you can say average amount of what you already have. So the formula is for average rate. If you have an amount equation, what would that be? How about if you want the average of what you already have, like the average temperature, or the average velocity, velocity.
B minus a integral a to b.
Now, what if they give you an like 1/5 integral from 0 to 5 of, and they say interpret
1/5.
1/5 integral from 0 to 5 of a quantity.
Average value of the quantity from
Average value of whatever is inside the integral, but don't forget to say from t is this to t is that for unit teachers. They want to hear you say it. They want to see you say it. Motion, you guys know what to do, increase and decrease, and just keep an eye on the wording. And my advice, amusement park stands,
Yeah, I was looking at those.
snow, bicycles, gravel processing, whatever you want to
ease. Hey.
Bees. Ins and outs and all that sort of stuff. Just keep an eye on the wording. And when you, if you, I know some of you guys have different strategies for skipping around or for seeing that you're like, oh, I'm not strong on this, I'll come back to it, etc. But in the FRQs, you answer it. You've taken the time to read it, to think about it, to start solving it. Just do a quick skim of the question. Make sure you didn't miss anything. Okay. Besides that, oh yeah, I'm going into particle motion. What are the candidates that we always check for absolute maximum, the greatest, the least, etc.?
Endpoints.
Endpoints.
And then
Endpoints. Critical numbers. And we plug into where?
Original function.
Ooh, how many of you guys have brushed up on Euler's lately?
I mean, I think I did it recently, so
Slope fields, hopefully we're good on that. The separable differential equation. Oh my goodness.
slope
So many
fields.
points. Just multiply by dx or dt. Integrate both sides. Use your clue to find C. And then carefully solve. If they do decide to talk about domain, you can go back to the absolute value function. Think about the zero of the absolute value for like c times e to the. And think, okay, well if this is greater than, if this is less than, talking about the different points. But don't stress about the domain. It will be 1 point out of 108. If they do decide to bring that up, that's something that might show up as new here. But it would be literally 1 point, no stress. Don't forget your squiggles on Euler's method. And don't forget that even though, depending on where you study, how you study, remember it's just the differential equation multiplied by delta x. So don't get confused by that notation. But that notation does remind us as far as approximating the tangent lines. Very similar. You guys all did great on mice minus lift. This is different notation, just use our forever cards. You did great on mice minus lift as long as you realized that we were running for the original population versus the rate. That's where we got a little stuck. You guys know that it's growing the fastest when the amount is half of the limiting constant, half of L. And the limit to infinity is that limiting constant. Speaking of limits to infinity, what's the limit to infinity of tangent inverse?
Pi over 2.
Yes. What negative infinity?
Pi over 2.
Remember your tangent inverse? There it is. Hey, that showed up in improper integrals a lot. You guys are mostly okay on this as far as vertical tangent lines, horizontal. We've practiced that recently. When can the second derivative test be forced upon you for relative extrema?
When they
You
don't
use
get the
sharp.
first derivative and then you need to say like f prime is 0 and f double prime is greater than 0.
Or in parametric, but you can't use a first derivative test.
Can't use the first derivative.
It's more like when you only have 1 point. If you only have 1 point and you have a differential equation in terms of x's and y's, you can plug in that 1 point and know the derivative at that 1 point. Know that it's a critical number, it equals 0 DNE. But if you don't know any other points on the curve, you can't test before and after. So that's when you have to go. That's when you have to go to the second derivative, which just happened in parametric, but it can also happen in functional also. Just keep your rationales clean, neat.
But can I use the first derivative in
If you have
parametric?
multiple, if you have points that
Okay,
you can plug in.
just that's good.
Yeah, you technically can if you have points. The problem is if you don't have points, go to the second derivative. And you guys know they usually say like find the second derivative, and so they're leading you that direction if you know if you can expect it. For the over and under estimates, if you're approximating, let's say with a tangent line, and they ask whether the tangent line is an over or under estimate, what do you guys think? Concavity. Huh? Concavity. Just concavity.
Increasing, decreasing,
So,
decreasing.
If I can say that my function is concave down, tangent line's above, no matter where, visualize things, it's okay. Concave up, tangent line's below. What's the other two things that they might ask us for over under estimates of?
Riemann sums.
Riemann
That is
sums.
when it's increasing.
Riemann sums, increasing, decreasing based on left. If it's increasing in left, what would that be, guys?
Under.
Okay, so we're gonna go under the
Because
curve.
it's strict.
Strictly increasing. You have to, maybe you'll show that, maybe they'll say it.
Because it could be concave up and increasing.
But even, no matter what, left is still under.
Well, I mean, if it comes back down now.
No, it's decreasing.
Right, that's what I was
So
saying. It's not
decreasing,
strictly
yeah.
decreasing.
Yeah, so it depends on increasing or decreasing over the interval. Over the interval. What about trapezoids? If you're approximating trapezoids, how do you know if that's under or over?
Draw a
Concave
big
down,
one and
over.
find a way.
Yeah, exactly.
Concave down over.
But it's all to do with concavity. It doesn't have to do with increasing, decreasing. If it's concave up, a trapezoid is going to jut out no matter how you draw it. If it's concave down, a trapezoid. So just I would say visualize to be safe.
Draw little pictures.
Yeah. But remember, if you don't necessarily want to show tons of your imprecise work on your FRQs, or if you do, you might want to put little X's through it, just in case you make a stupid mistake. You don't want them taking points off if you know that this is the answer and this is what you want to do. Does that make sense? And you guys know everything with the calculator. If you need to find intersections, so the way you write the variables that you go ahead and have it. You guys aren't necessarily worried about the situations they can throw at you as far as like gravel or snow or anything like that. You guys are used to it. Other than that, remember this year what is different is that the timing is a little bit different. FRQs are the same. If you have 30 minutes and 60 minutes with a multiple choice, remember you have 30 questions and then you have, so if you've been doing them on bonus exams, I just don't want you to be thrown off at the very end. Remember, it's not 28, it's 30 for the first. Other than that, I pretty much agree with all of that stuff at the end, and you guys are okay.
So it's 30 questions on the
30 questions on the first part of multiple choice. So you have 30 and then you have 15 instead of 28 and 17.
Oh,
So you're going to have an hour on 30 questions and I think 45 minutes on 15 questions. Yeah. So it's like the one that we took on Saturday.
How How do they decide what the time limits are?
Round up.
I think it's based on, I mean, they do so much student testing of this over years and years and years and years. They just kind of said this is what, in order to get the scores a certain way with a certain distribution, this is the ideal way. And like for the 30 and for the 15, it's literally based off of the 28 17 they had for like 30 years. Okay. Yeah.
Can we do something special if we all get 5s?
Yes.
What?
I think at the end of the year I always do special things, but I don't know, you guys can be thinking about it. Not during the AP exam. But if you need a quick little study break, you can go over it. Alright. Besides that, does anyone have any practice problems where they were working on something they got stuck, or do you have anything you want us to look out for in this pretty much brand new exam that we haven't looked at as far as BC content yet?
Like something we want to warn each other about?
Yeah, or something you want to look at, whether logistic or orders or parametric.
So they were fine if they ask you for a certain like I've
If you
noticed.
find something in, let me know too.
I noticed that every single time I get the same mistake. They ask you for like a certain term, and you plug in that term, and it becomes like a term. Like if they ask you for the 5th term, and you put the 5th term, it becomes like the 10th term because of the squared. So watch out for that, guys.
P.S. How are you going to solve this one?
Fun trick.
Partial fractions. Oh, boy, there's nothing. Convergence, divergence, you guys okay?
Can we do that one actually?
Yeah.
We haven't done those.
It's been a while. Yeah, that's what I was thinking.
All of them.
Not A.
Well, you can compare if you know one convergence or if one divergence.
Well,
We know it's not A.
it's not a. Yeah, right.
One down.
Divergence test, right?
Wait, why?
Because it's
Oh, because the
limited.
You guys want to integrate B?
can we compare it to a model?
3 over n here. The problem with 3 over n is that diverges, right?
So if it diverges.
So as a limit comparison test go, that a lot of us miss that forever.
Far.
It's a bigger concurrence.
Oh,
If it equals
The limit?
if it equals a constant, then if one converges, the other converges.
And if one diverges, then it diverges.
So always do the one that equals a number.
So the limit is greater than 0 because 0 is constant.
If it equals 0, it converges. If it equals infinity, it diverges.
If you're comparing with a convergent.
Yeah.
Wait,
So those have to be the one or
If it was
the
a
other.
constant, it converts.
They both do the
Only,
same thing,
yeah.
no matter what. But if the limit is 0, you can only make a conclusion if you're comparing to a convergent, then it converges. And if the limit is infinity,
Then it has
you
to
can
be
only make a
divergent.
comparison if the other one is divergent, then it has to diverge.
So find a constant.
So why was I saying compare to 1 over or 3 over n?
because that diverges.
No, it equals 1.
What are you talking about? Yeah, it equals 1. And then
You could.
diverges.
Ratio
Oh,
test is
yeah.
pretty nasty nowadays.
I mean, we just
Because
there's
we
a
have
lot
the
of
n plus
cancels.
1s.
We just have a lot of cancels.
Can't you just multiply by
The 3 and an n plus 1 wouldn't cancel. But you could go ahead and think of the ratio test as far as the conclusions. It's not as nice as roots that cancel.
You could just make it easier though and do n over 3 for that one
Yeah.
also. Or 3 over n.
Because then you have 3n squared over 3n squared, which the limit is 1, which is greater than 0.
So they both diverge.
So 3 over n, yeah, that's going to be divergent.
It's E.
And if you keep on going, can't you try this one? n over 3 over n as well, right? So you're going to have again, divergent, and then if you have 3 over n, once again, divergent. This is going to equal a constant. So what's going on in this one?
It has to be that one.
Wait. If it equals 0,
That's this one, right?
yes.
Then
It
I
says
can
that
only
diverges.
make a conclusion if this one converges, which it doesn't. So right now,
You can't do
that
that.
test failed. Yeah.
But since all the other ones diverge, we can say that one converges.
3 over
Yeah.
n squared.
Yeah, you could do that. Or you could try 3 over n squared. So n squared over 3. 3 over n squared converges, and it equals a constant. I would have thought limit comparison would have been the easiest one. Because if you'd done an integral on that, you can integrate all those. Right? But ratio is a really practical one, right? And limit comparison, I would say those in nth term test. Besides like geometric series, series, those are the most commonly used. I'm not saying they're the only ones, but they're the most commonly used.
Do you have faith that they're not going to have to ask us about direct comparison tests? Because they really don't want to do that.
Technically, on the new revised, they do say that direct comparison can show up. I'm not sure how they're going to ask it, how they're going to force it, but they might give you one of those like, hey, A is less than B for all. So they might, because if you guys on that Saturday mock EP, there were a couple of those concepty ones, like the limit definition of an interval. So they might throw something that gives the conditions of direct comparison.
Hours for PSI.
Yeah, exactly.
What the heck was with that one? That was
No,
so dumb.
Well, no, what they're doing is they're testing that you haven't just memorized things, but that you understand the calculus and the math.
Yeah.
So they try to trick you. What else do we have? Integral of e to the pi? Don't you dare. Isn't it just e to the pi t?
Yeah.
Okay.
Don't you
What are you going to use on this one?
The hospitals.
Yep, I would say L'Hôpital's.
I'm going to send them to the hospital for changing the letter.
Oh dear. You guys have a logistic one right here. Are we okay on logistic?
Let's do it, YOLO.
All right, logistic. Wolves.
Ha!
Why is it logistic?
Because it says so.
Okay, line. Ooh, hold on. How can we get this to look like how we want it?
Divide out to 5,000.
Hold on to 5,000.
I guess you could say 1,500.
So you do 5 over 5,000. When you divide by 5,000 or divide by 5,000. You okay?
Would that be 1 over 1,000?
Which of the following statements are true?
The
Yes.
first one's true.
The first one
because
is
that's
true.
L, right? That's my limiting constant.
Positive for t greater than 0.
Yeah.
So you know.
Oh, just it goes right.
Yeah.
So d dt, that would be the slope. What's true about the slope?
Constant increase.
No. But constantly positive, yes.
Yeah.
Constantly increasing to the point of inflection, which happens at 2,500. So why am I going to say no?
Because it's got a concave up and a concave down.
Which occurs one more time? Where? Where's
Yeah,
the
ha- 1 over.
Here.
There's 1/2.
Yeah.
Never mind.
Or you can put L on here.
So constant at, and that's the y, not the x, right?
Mm-hmm.
So then that's the p, not the t. So if you needed the t, you have to plug in somewhere.
True.
We're still looking for Taylor and McLaurin, though, I think. We're halfway almost through the first section. That's all graphs. That's just polary stuff. You guys would be careful of your bounds and then graph it. No, it's non-graphing calculator.
So we just set, can we set them? I don't understand why we can't set them equal to each other and then find the other side. How can we do that? Wait, let's theta equals 0. You have a circle with 0 radius?
No. That's just zero angle, remember?
Oh, my bad.
That's just zero angle. And then I have pi over 4. So I'm pretty sure you can just use, look at, guys, don't stress. Look at all the bounds. You're good. You don't have to worry about the bounds, right?
Wait, no, that usually helps, doesn't
If it's one of the complicated intersection ones, but this one, they literally just gave us the bounds, like for area, if they're trying to find area between, and they give us from A to B, they just gave us from A to B. All the bounds are the same. Now, however, how do we find the area? What's the formula for a polar region, a polar area?
1/2 integral a to b r squared. That's what c.
So the only one that fits with 1/2 and then r squared, because you square the 2, becomes a 4, 1/2. There we go.
They're trying to trick you to see.
Yeah. Yeah, they are. What do we do in number 16? That's a Taylor and McLaurin, right?
It's going to be n over n factorial. Isn't that like talking? Because you know that that's e.
Remember definition of derivative, how we can plug in an x value and you have to realize it's an x to plug into f prime? Same thing here. You have to realize the special Maclaurin series, and which one is this? So then e when x is 2, e to the x, I should say, when x is 2 would be b. Ellen's and Robbie one, right? Isn't that Ellen of minus x? We don't just have them for
Yeah, it's 1 minus.
oh,
It's not
I
something.
think it starts on x.
and then we integrate that to get the L.
Wait a minute. Ln is x minus x squared. Ln of 1 plus x is x minus x squared.
Ooh, number 19.
You said something about integrating to get LN?
Oh, we have the special Maclaurin for 1 over 1 minus x. So we could write out that series and we could integrate term by
Do you
term.
not have it for 1 over x?
There isn't really one for that. Is it 1 plus x?
Ln of 1 plus x.
And if it's a minus, you can do plus or negative x, right? Yeah, check out that forever again. But we integrate in order to get ln of 1 plus x, and then we can fill it out with that. Because remember the Maclaurin series, we don't mind dividing or integrating or plugging in. Alright, cool kids. This one's hard. We're asking for the coefficient in the Taylor series.
Just derive that. At 0.
Just derive that?
Derive at 0.
Because for the x cubed term, think about our definition. They haven't given us anything weird. So what's the x cubed term going to be?
The third derivative at 0 times 3 to the power.
Then what's that derivative?
Sure. 1 half 1 plus 3x is 3 halves 1.
Times 3. And then don't forget to use that. Or plugging in.
1 plus 3x to 1 half. Negative 1. Where are you guys getting 6?
You just want the derivative. So we have to. They could ask you for the derivative and give you the term, and you have to work backwards for the factorial, or they can give you how to find the term to get from the factorial. So long story short, bring down the 1 half, and we'll put our 32. Is that good? We would do ratio test, right?
Yes.
Interval of convergence. Don't even need to test the endpoints, true?
But can't you just do root test? Play that easier. Oh, basically.
Interval of convergence.
Never mind.
Careful. You guys said Taylor, so I'm looking out for that, but there are other convergence and divergence. Horizontal asymptotes, be careful of positive and negative infinity. That's an f of u times u prime. That's a derivative, right?
Yep. Sign of x.
Ooh. How's the derivative of an inverse?
So
One.
x and y.
1 over f prime of f inverse.
Something else, 1 over cosine of plus 2 times
1 over f prime of.
You can't just think 1 over f prime of. But the problem is, can I just plug in the 1?
Yeah,
The 1 is the x of the inverse, which is the. How am I supposed to figure that out? Then now we have to refine.
Subtract 1.
Yeah, you could.
We got 0.
Negative. This is
Trial and error. Try 0. Sine of 0 is?
0.
0 plus 0 is? Now I just guessed. If it wasn't 0, I try 1. If it wasn't 1, I try 2. If that wasn't it, I try negative 1, negative 2. They've given me one that you can trial and error it. It's going to be a nice, even, small number possibility.
Wait, you're supposed to be plugging
There's
this.
no way to solve it. Right?
Oh.
So you just start at 0, try 1, try 2, try negative 1, negative 2. So it's going to be the inverse. Almost always. I know it's imprecise. Go ahead and plug in 0. Plug in 0. 2 times 0 is 0. Cosine of 0 is? let's say the derivative of each side is still 1, and I took the derivative of that. That was dy dx, so I divided.
Can we just switch
You
that
can,
to y if even though there's like the sign? Because isn't the inverse of the sine of x would be sine inverse of x? And the inverse of 2y or 2x would be. You know what I mean?
inverses don't work in, you can't just invert each piece, it has to be the inverse of the whole function.
Right, but just switching them with inverse the whole thing. Because I thought it was that we have to.
Well, remember, pause, we don't have to find it. The derivative of the inverse is 1 over f prime, so you could have just taken the derivative. Just remember, don't plug in 1.
It's
You
C.
just wanted to go find it.
Derivative of 2 is 2 x is 2.
Oh, thanks.
And then we don't have to do this way?
And it's not C, it's A, right? You don't have to do it this way, just maybe say switch x and y, that's the way she was thinking about it. You can just use the 1 over f.
Hold on. See, if
Yeah.
you want to do the trick, it's like f inverse prime of a equals 1 over f prime of b.
Mhm.
Right?
And so this is A, and I can't use him, so I have to go plug him in. And the x of the inverse is the y of the original, so we had to go find B.
So you have to solve for the x, and whatever the x is, you plug it in for the.
F prime. Alright, kiddos, the next section is going to be. Ooh, do we want to do one more Taylor and then call it quits on this one?
I kind of should call it quits.
Yeah, 'cause it's a Lagrange error.
Third degree. So for approximating with the third degree, what's the Lagrange say? 4. So we're trying to think about f to the 4th, right?
Z.
Z all over times, where's the sum of that? About 0, right?
X to the 4th.
Where are we approximating it as? At?
1.
And what are you going to use this for?
Figure out Z.
So the n is just going to be 4. And then 4 over 4 plus 1 is 5. All over 4 factorial.
Wait, so it's 1/2 or 4 over 5.
We're figuring out what Z is. 4 is the biggest.
We don't need.
So what needs Z?
Yeah. There you go. Okay, yeah. 4/5 is 3 and 1/2.
We don't need.
We just need the entire term. They just want all Lagrange. So all Lagrange. There we go. So we end up with, what was it? B, right?
It's gonna be.
Alright, cool kids. Let's get out of here. Let's get away from the specifics. Let's get away from the what to expect. Let me just close everything out. You know to study your forevers endeavors. You don't need me to tell you that. You know to look over your when you see you things. You don't need to tell. You don't need me to tell you that. You want to play for 5 minutes? Let's see. We did 500. We did that one. We did 100. Yeah. 4, 5. I'll look breakfast ready in the gym probably around 7:15. You guys are sitting down at 7:45, so sometime in between. Sometime in between.
Can you test this expert one, please?
These are your scented ones, right? That you like.
We did turn bio.
You know, you stole them from someone else. I don't think we did any. Did we do any trig derivatives?
Did you get one minute?
I think we did 1.
You did Juan.
We did 200.
The first-
500 parameters.
The first related rates was like a 200 something.
You did 500 parametric?
Yes, we did do this one.
I feel like we did a related rates, but maybe we didn't.
We did at the very end. It was
Yeah.
the latter one. 200.
They think it was 200.
Nope.
Wrong.
Okay, ready, set. You guys chose it. Go.
What's the volume of cylinder?
Was pi r
Go.
Pi r squared h.
George, you were thinking sphere.
Oh.
Except sphere is
Ah.
4/3 in front.
I know something.
I never understood that. If we want volume, and volume is a cubic thing, then how are we having a square?
How am I going to do those?
No. R squared
Okay.
and H. We have a cube.
So-
which is
She knows she is.
Just trying to remind you that the radius is constant, right? Think about the cylinder. The radius is constant. There is no drdt. Plug in 3 at the beginning.
Keep
You don't know, like, I'm taking names.
Oh, I don't know that.
I didn't, of course you don't know.
I'm done.
Like, please.
Oh, I didn't put. Whatever.
Big units?
I think units, but we need to put the h. There we go. Done.
Signs up.
So,
Oh.
that first try.
First try?
We did like
Remember, if it's pumping out, isn't that the volume changing?
Yeah, I got it. Thank you, bro.
So -2/9 pi. Any units work?
Yeah. Units per minute.
Matt, can you tell me that?
You just drop them off on the side table. I'll be here after school if you guys want anything. Please,
Yeah.
please